So welcome. Today we are going to see the conventional heat pipe, that is the heat pipe with weak metal. So first of all we are going to prepare the geometry, then we'll prepare the mesh, and consequently we'll see the analysis how it has been performed. So let's start with the workbench. So we are starting with the fluid flow fluent option. We are preparing the geometry first, and then we'll proceed. If you have already a geometry, you can okay. So this is first one. Click on any one of the plane. First of all, set the units. So I'm going to go with the units, that is mm, and will proceed accordingly. So first of all, click on any one of the plane. This one millimeter, the unit which you have selected. So first one, creating a primitive. First of all, cylinder will prepare. So I need this orientation to be in this y direction. So accordingly, we'll change this. So z component, instead of z component, I will make it y component. Say one y is 140. That is in make this component as 0. So now this is the orientation we can see in this direction. Radius I need is 3 mm. So accordingly this geometry is been there. So let's take it somewhat down. So first of I will generate this geometry. So diameter will be 6, radius we have taken as 3 mm. So this is the first thing which we have done. Now we'll generate one more cylinder over here. So that will be again a primitive, that will be cylinder. So I will take the orientation slightly in different direction, not like this. So I need this again to be in z direction, sorry, in y direction. So I will make it 140. Will make this as a 0. So z component I made this as a 0. I will take the radius, that is equal to say 0.1 mm. So very small radius we are taking. Now it is at the center. I don't want this to be at the center. I need to shift this on x direction. So accordingly I will shift this component to say 2.91. You can see in the positive direction. So here it is the object which has came. You can just zoom in to this particular object to check whether it is outside the given geometry or not. So this is the first thing which we are doing. So instead of this add frozen, will make it slice material and will generate. So you will be having two bodies which are being generated here. Now later on I'm going to remove this particular part. So that can be done with the help of boolean operation. So boolean, instead of unite I will make it subtract. So here so first of all, this is your target, make it apply. This will be your tool, make it apply and click on generate. So you can see this part has been removed. So this is the first one layer which we have generated. Now I need such layers on whole of the geometry. So accordingly we'll make slight changes. So we have to go with a pattern option available. So instead of making linear pattern, I will make it circular. First of all, select the geometry. I'm going to make this as a face which I want to repeat. Make it apply and then select the axis. So properly select the axis and how many copies you want. Say I specify it to 30 and it is to be evenly spaced. So you can see the geometry is full of, okay, we'll check out some other view. So the geometry is full of we can say this kind of grooves which are been available. So this is the first thing which we are going to proceed. So I need what we are doing is we are making the fluid zone which is available inside, and based upon the fluid zone we are going to do the analysis. So that's why I'm making this as a fluid zone which is in contact with the heat pipe which has certain kind of grooves which are been available over here. So this is the first thing which we have done. We have prepared the geometry. The geometry has been prepared. Let's take a quick look of the geometry which is in this particular direction. Now we need to slice the geometry at some over here. So we need to create some planes. First of all, I will create one more plane which will be from base plane. I will take this is ZX, so make it apply ZX, then transform this to offset Z, say for example 20, and it will be shifted up. So make it generate. So the plane has been generated at this point. So let's do the slice operation with respect to plane 4. Now your geometry will be divided into two, this one and this one. Okay, so right now both of them are fluid. We'll go on to rename this later on. So this is one plane which I have generated. Now next thing is I need the evaporator section. So accordingly again I will make this as a from plane here. Base plane I will take as a ZX, make it apply, then offset this again Z. So here I will take this as 100 over here. Total length we have 140. So accordingly I have taken this is 100. So make it generate. One more time go with the slice operation over here, click with respect to the plane, make it apply, and then click on generate. So your body will now be divided into three parts. One, it's the top which will be called as the evaporator. Second, the below, sorry, top which is called as condenser. Then this is below evaporator and the in between part. So these are the three sections which have been done. So one more time I will go with one more slice operation. Why? Because I need to specify to what portion the fluid has been present. So because of which I am creating one more plane. So that again has to be taken from plane. I will say ZX as a base plane, make it apply, and I will transform this in the Z direction and will say here 90. So slightly below the condenser section we have made this and make it generate, and one more time you do the slice operation. So with respect to plane 4 we have done the slice operation. So what will happen now, this is the zone we are will call this as the liquid which is present. Here the condensation will takes place, and this is the space which is left with the air gap. So accordingly the things will be proceeded. So first one, this is the portion which is at the top. So I will specify this as air. This is again the second bottom, so it will be full of water. So I will say this is water. This one, it is at this point, this will also be with the filled with the air. So I will rename this as air. And last one, this will be again filled with the water. So accordingly we have things like these are the three for your air, these are the two. First one air, this is also air, this is a water, and this is what water. So this much portion it has been filled with the we can say the fluid. Remaining we have the empty space which has been available. So based upon this we are going to proceed with the simulation or proceeding with the mesh as well as applying the boundary condition. Now if somebody want to check how much is the water portion which is available, so if you can see the if the volume has been available, you can just check it out. Okay, the volume is actually not okay. Okay, the volume is not been available. You can we can say divide the geometry in such a way that we say how your objects are been there. So accordingly this can be done. So first of all, this is the first part, this is second part, this is the third part, and this one. So accordingly we have we can say divide the geometry, and we are going to proceed with this particular we can say geometry. So first of all, save the work which you have. So try to save this with the help of whatever the name you are having. So I will say this is a conventional heat pipe, or you may call this as a heat pipe with wick. Okay, heat pipe with wick structure. So make it save, and accordingly we are going to proceed with this particular case. So first part is over. So regarding the preparation of geometry, we have given the names also, we have sliced the geometry also. So next part will be to proceed with the we can say mesh part. So before that we need to uh, just a minute. Okay, now next part is the preparation of mesh. So first of all, I will generate the mesh. I'm not sure whether the mesh, the default mesh which is being generated are within the limited number of nodes and element or not. So I need to check out whether it will be within my student version of ANSYS. If it is not there, I need to change the size of mesh. So this is default size which you are taking. Normally the 5,12,000 nodes are been possible with the help of this. Okay, just check it out how the things are proceeding. Yes. Okay, so it takes time, so maybe the mesh which is generated may be too much of fine as a default mesh. So I will check out with the statistics how many number of nodes and elements are been there, and accordingly, so this is a quite bigger value. So this will not be possible with the limited version of student ANSYS. So I'm going to change this value of mesh over here. I will just make it 0.021 and will generate the mesh. Just check it out what will happen. uh, I had taken this 0.021 because I have already tried with this fitness simulation, and that's why I have taken this value. You might need to check out this value, which will be less than 5,12,000 nodes and element. So some trial and error may be required when we are proceeding. So by default, I have taken it as 0.021 over here. So generate mesh, it has been done. Now it's a time to give the names to the particular you can say the portion. So first of all, I will try to zoom in this particular part, and then I'm going to proceed with the name selection for this particular. So name selection has to be done carefully. So first of all, select all of your faces which are been available. Okay, there should not be any spaces left. Okay, so this is one thing which I had done. I will just try to change the view of an object. Okay, slightly see. Now while selecting, I have not been able to select the internal parts, so that internal parts need to be selected before proceeding. So this has been missed out over here. So I'm going to select all this before proceeding. Sorry, let's make it again. So we need to select all over here, whichever is present from both sides. You should not skip anything because we want to apply the boundary conditions. So that's why it is very important that you should select each and everything which is available. Okay, now I will slightly zoom in this specific part. Okay, now I will select the internal faces which are been available. So this one, sorry. Not this. If I check out this one, say with the help of name selection, say I say this is heater. How many faces? There are 54 faces which are being showing right now. I am selecting all inside faces which were left, because this is very important to proceed with. So slightly orient the geometry in such a way that you are able to select the faces which are not been selected earlier. So this one has also been there. This one is also there. Okay, sorry, one more time. So select all of them. This becomes tricky somewhat. Because you need to change the orientation as well as do the selection. So slightly make it in better visualization for you. So one more time. Okay, this is, if you leave the control button, the things will not work for you. Okay. So try to select whatever things you have not selected earlier. Okay, I have selected this part. Now let be. So check out if anything is pending. Otherwise it will go on to make error, or you will not be able to apply the boundary condition properly. So this is the thing, carefully it has to be done. I will just slightly zoom in to this part just so as to check whether each and every things are been selected or not. Okay, I hope it is, most of the things are been selected. Yeah, now make it apply. So it shows 63 faces. Check out if anything is pending. I don't look, so if anything is pending, doesn't look to be pending. Okay, so let's have another view so that we can check out if anything is pending or not. Yeah, so this is how first thing which has been done. Now this is done for the heater section. Same way we'll go do it for the condenser section. So let's orient this again properly. Okay, so this is going to be again the next part. slightly zoom in. So we'll go to select each and every face. So select all this. Okay, and this is we don't want. Okay, so let's take it on the other side. Yes. So slightly zoom in. Okay, so this is the next part which is left. I need to select all so as to proceed further. Now just check if anything is pending. Let's have different orientation so that you will be able to visualize it in quite proper way whether you are selected each and every. Okay, one thing is this was left. Okay, now just check it out. This one, I think we have selected almost all. So now go to the create name selection and specify this as a condenser. So 62 faces it is showing. Maybe one of them might have missed. Just check it out. I think we have completed, so might have missed one of them. Just see. Okay. So make it update. See first. Mesh translation to Fluent is successful. One more time. Just check it out with if anything is pending from our side. This one is completed. Yeah. So it might take some time because this is a time consuming process. Okay, so this is how the things has been proceeded. Now we can run for the simulation. This is the portion which we have specified as a heater. Let's zoom in one more time to visualize the thing. So this is how we have specified the heater. We have specified this as a heater and we are going to proceed with this particular section. Okay, so make it update one more time and close this mesh. So close the mesh. Now let's move to the setup part. So double precision, should say type 4. Make it okay. So depending on how many cores you are having, so accordingly we can proceed. If it is not within the license version, it may show some error and we have to go back and change the number of cores. Okay, so as of now it is not showing. So it shows mesh adopt set method Puma. Okay, done. Now we are done this. So let's make it okay. So gravity, it has to be specified minus 9.81. Then I will say transient. So first of all, multi-phase, I will select it, volume of fluid, implicit body force, make it okay. Close this. Energy equation, we need to turn it on because we are applying the temperature as a boundary condition. So make it okay. Instead of K, we will have K epsilon, enhance wall treatment. Then we have thermal effects. Then we have curvature correction. Make it okay. So this is the first thing. Next thing is go to the material. Right now I'm going with the default material, that is water liquid and water vapor. I'm going to make it copy and then close. So change rate, you can close this. If you want, you can select copper, then 381. This is 387.6. So this one is, I will say copper. This one I will say this is Cu. Change grade, make it yes, and you can close this. So this is first thing. Then cell zone condition, you meet operating condition, say for example 4000 pascals, make it okay. Then go to the your multi-phase, then specified the phases. Phase 1 I will say steam, water vapor, make it apply. Phase 2 I will say it is water liquid, okay, make it apply. Then go to the phase interaction constant, I will say 0.0736, as the diameter is quite bigger, so surface tension effect may not be that significant in case of your closed loop pulsating heat pipe. So water steam, I will say evaporation condensation, say boils at 303 Kelvin, make it apply and close this. So this is the first thing which we are done. Now it's time to apply the boundary conditions at each and every section. So let's make the boundary conditions. So we'll specify this is 20. No need to change the thermal condition over here. I will keep this as it is. In case of heater, we are going to apply the temperature. So let's make it 20. Let's have this one like 343 Kelvin. Make it apply and close this. So next one at walls, I'm just going to apply the 20 as a contact angle. Nothing other things will I'm going to change. Make it close. So this one, this is 20. Then again this is, make it 20. Close. Every boundary condition you need to change. Make it say again 20. And then close this. So once this is completed, then you can run the simulation. Again, the things will be slightly different here because the geometry is different. We have changed the mesh size also, the what is different. So everything is different over here. So slightly in setup, the things will go on to vary with respect to what we have done in case of the closed loop pulsating heat pipe. So next is this one. Again, specify this is 20. Make it apply and close this. Let's have this one also. Make it 20 and apply the boundary condition. So this is the first part which is related to applying boundary condition. We'll close this. Now go to the initialization over here. So initialize, make it patch. It will be water. Volume fraction I will say 1 and this one is water. Close. Now this one calculation activities, I will say this is 20. Then solution animation, here I will set new thing, that is contours, and I will go with the phases which have been available. Volume fraction of water, instead of this exponential I will select it float, make it apply and then close. So here I have the walls as a boundary condition, so make it apply. So here you can see, so compute, and this is, I will say this is if you want you can give the names also here. I'm keeping animation 1 as it is, only thing I am changing the view of it. Say it is front, make it okay. Then go with the run calculation. So instead of fix I will say adaptive, make it 100 right now. I will say this is 0.405 and then I will run the simulation for this. So let's start. So we have started with this one. It can take more time because the mesh size is quite we can say fine. We have taken almost for like 60 or 78,000 nodes and elements, so that is likely to change. Say the time required will be quite huge in such situation. Again, we need to check out with the problem of current number that can happen over here. So meanwhile, whenever you are running the simulation, you need to check out for all these things, whether your value of current number is going quite higher or not. So if these values are coming higher, probably you might need to go with changing a time step size. This is one option which can be done. Again, you can observe the residual. If it is going in the proper way, you can sure that whether this problem will come or not. If they are coming quite nearer, then probably there could be the problem of current number. But as of now, it going in the proper way. You can just check it out with the current number also, which has been available. If that value is quite higher, so there is likely chances that we can say the problem may occur. But we are proceeding with the simulation, so it might take more time, and accordingly we'll check out how the things will happen at the end of this 100 time steps. So we have reached around 7,000 iterations. So two time steps are remaining. I will check it out how things are going on. So we have completed around 350 time steps and 7,000 iterations. So this, okay, 350, you can just check it out. So it shows around 350 time steps, and this how this the process has started. You can see at the bottom. At the same time, you can see at the top also. So this vapor started to move up. So this is how the process. So let's save the work. We might need to continue it for more number of time step. There is one thing that has to be remember is if there is a problem of current number which is taking place, you might need to reduce the time steps which are required, and accordingly we have to proceed further. So that is how this is important when you are running the simulation. I may just try to show with the animation. In the animation it may not be much things available, but say if I take it 10, you can see it is slightly going up. So we haven't done with many time steps, so that's why it will be very difficult to visualize this. So once we have more number of time steps, then it will be quite easy to understand how the simulation has been taking place. So let's start it again. So around 7,000 time step 7,000 iterations and 350 time steps are there. So we are started it again, so for 50, so it will end at somewhere around 400 time steps. So we have to continue this for a long time in order to visualize better results.